We'll just do that page. Just turn it off. Okay. All right. So good morning. Convert the given degree measure into degrees, minutes, and seconds of arc. So again, there are like 60 minutes in 1 degree. There's 60 seconds in 1 minute. So they want us to do this converting sort of thing. So I think the way I have this approached is I have it set up so you can give it a roll. You gotta find the degree sign. You gotta find the minutes. So minutes is what, 1 little tick mark, and then the seconds is 2 little tick marks. And hopefully I did the formatting correctly so that it accepts things. So we want to convert this into degrees, minutes, and seconds. So we start off, pick off the whole, and then deal with the fraction. So if you have half a degree, how many minutes is that? I'm kind of baffled that like 7 people are here, to be honest. This is That's including me. There are 7 people here, and the day before a test. Which reminds me, there is a practice exam, and none of you have done it yet. So y'all need to go and try to do the Respondus Lockdown browser. There's a little practice exam for you to try things in. Try to get that thing uploaded. And try it out before the test on Thursday. Oh, what are y'all doing? 30 degrees in minutes. You're writing out 10.2. I don't know where that's coming from. You're writing out the words. All right. Which is okay. Yeah, it's fine. All right, going over how to do this. You're going to pull out the whole 32 degrees, and then we're talking about 32 and a half. So we talk about the half degree. So for each 1 degree, there are 60 minutes. And so hopefully it should look something like 32 degrees in 30 minutes. Oh, I think y'all can do this in a minute. That's fair enough. So hopefully you got a calculator. If not, you got to run and drag over with me. Maybe a few seconds longer. You got to find the symbols in the alternative keypad in the back. So I would suggest using the symbols. That's what I put in there when I did the solution. So the degree sign, you have to find the degree symbol. Find the minute, you're just using an apostrophe. One apostrophe for the minutes, 2 apostrophes for the seconds. I think I put a space, but I think I also did it without spaces. Where y'all putting it? Where y'all doing? 149. Ooh, got it right, but is it not counting it correct? A lot of these look correct. 149, 49, 48 should be it. It's only counting. What's it doing? One of them correct? That is really weird. Okay, so Same one of them said 49.8. So this one you have to pull out a little bit more. We start pulling out with the 149. And then we have 0.83 that we multiply by 60 to get the number of minutes. And then after this, we also have to pull out minutes to get to seconds. So we have 49 whole minutes. We have 0.8 fractional minutes that we convert to seconds, which will give you 48 seconds. It should be 149, 49, and then 48. I think a few people got that one. Okay, and this, I believe we're going the other way around. So we want to convert this to a fraction, round it to 2 decimal places. Pray to the machine gods that they like your formatting. Again, there are 60 minutes in 1 degree. There are 60 seconds in 1 minute. So they go the first way. We were multiplying. Now we're going the other way. And we want to go to degrees. So we're given something in minutes and seconds. We want to go to degrees. First, we're given degrees, and we want to go to minutes and seconds. Oh, yeah. Oh, man. Yeah. Did I not get it correct? How did I not get it correct? Oh, I forgot to put my degree sign. That's what I did. I guess I didn't even count it right. So I'm seeing some 8.99s. If I were to guess, it was probably something with this 10 that y'all did, if you didn't get it correct. So to go from minutes to degrees, we have to divide by 60. To go from seconds to degrees, we have to divide by 60 twice. So you could do it 10 divided by 60 divided by 60. It's another way you could do this. But basically, you're dividing by 60 twice. You could either divide by 60 times 60 over, or divide it by 3600 is another way you can do it. Any questions about this one?
Nope.
So this is to go from minutes and seconds to degrees. All right, and this one, now we're doing latitude and longitude. They want us to do the antipodal point, like you're going across, drilling through the center of the Earth. So if we're looking at this, doing latitude, if we use like if you think about like being a lever with like the equator as your fulcrum, right? So if I'm going up and I do a line straight through the equator, that line's going to go down, or a lever, like a straight lever going through the equator. If I go down, it's going to go up, and it's going to go up and down the same amount that I'm going up and down, but opposite, right? So if I go up, it's going to go down like a seesaw, I guess is one way to think about it. And it's going to be the same number, but instead of north, it'll be the opposite. So the opposite of north. And then this one, it does change to the opposite of west, which is east. I guess I could say that, right? But there's something about these lines. The opposite lines sum up to 180. So this and the other thing should sum up to 180. So if they add up to 180, how do you find it? What's that one? Okay. Oh man, am I gonna get the formatting right on this one? That's one person. So, okay. So hopefully you change both these letters, right? It should be 44 south. And then this one you got to do a little bit of figuring on. Y'all know y'all set the pace for the class, right? Just putting that out there. All right, man. Like, yeah, I've already hinted at how to get to this enough. Like, there's like one step you have to take. It shouldn't be taking this long. All right, so it should be 44 south and 101 east. And so 44 is the same. The 101 we're getting going from 180 minus 79. So the next thing we're going to talk about is Buenos Aires and Cape Town. And going back to that picture of latitude and longitude, what was this? Latitude, it starts with 0 at the equator, and it goes up to 90 north at the top. It goes up to 90 south at the bottom. So at the equator, it's 0, and it gets larger north, it gets larger south, is the way that this thing goes. And so now they want to know, the question that they're going to ask next is which is farther from the North Pole? And so hopefully you're thinking north and south. Hopefully you're not thinking east and west when they ask you something about the North Pole, right? So we want to know which one is further, the 34.6 or the 33.9. And so that should be the next question. Oh God, what was the numbers again? So we want something that's furthest from the North Pole, I think, right? I think they're both degrees south. So you'd want something larger, right? It has a longer distance from the North Pole. Yeah, I think it would be Buenos Aires. I don't remember the numbers. I already forgot the numbers.
I misread the question.
It would definitely be the larger one, right? I think I'm just going to hit end. Is the larger one is going to be the one that is furthest south. I think I say it on the next one. If I don't say it on the next slide, I'll definitely do it. I'll jump back. It's not letting me end. What is it doing? This is glitchy. Oh, that's another question. No, not yet. All right. So which one was it? It should have been Buenos Aires. It is the one that is larger. This would be further south, the way that it is numbered, the latitude system. Longitude is going up and down. Latitudes is like laps going around it. That's what it is. That's how I remember it. Sorry. Oh, man. Buffalo, New York is at nearly the same longitude as. Ooh, got to do a little bit of calculating on this one. But they are at the same longitude, but they are at different latitudes. One is at 43 degrees north and one is at 26 degrees north. About how far away is Buffalo from Miami? And we're going to use the fact that 1 degree of latitude going north or south represents about 69.4 miles. So I'll give y'all like 30 more seconds after this thing. Give y'all a minute. But there is just a little bit of number crunching, not a whole lot. We know that every 1 degree is 69.4 miles, and we know there are how many degrees that we're talking about. Which one's me? Oh, that's a thing. Is that a goblin? All right, so we got questions to answer. What's your approach to this one? How are we getting this one? What was that? 1179.8. Yeah. Oh, yeah, I put a comma. I don't know if I put a comma in my solution. That's what happened. All right, so a lot of y'all got it correct. It's just a formatting thing. Which slide is this? 11? Let me make a note of that and see if I can fix that. All right, so going from Buffalo to Miami, we are going from 43 to 26. So if you subtract those two, you're getting 17 degrees. That is a difference in there. And then if you multiply that by 69.4, because we have 69.4 for every 1 degree, you are going to get the 1179.8 that you're getting. So walking around the sun. And so this is one of those angular physical, what do they say? This formula. This is the formula that they give you in the book. The angular size is equal to physical size times 360 over 2 pi times distance. And so if we want to solve this thing for physical size, if this is multiplication and I want to get physical size by itself, I want to move all the rest of this stuff and it's being connected through multiplication. How do I move this? What's the operation I use with this thing right here?
Would you multiply by the reciprocal?
Okay, that's good. Yeah. I was going to go with the dividing first. And then that you can look at dividing as multiplying by the reciprocal. But yeah, that's absolutely it. Because dividing, sometimes they say copy dot flip. You're just going to flip this thing and multiply it. Same thing. Or you can just do a reciprocal. That'll make this thing 1. But this is the formula that we want to use. Physical size equals angular size. And we flip this thing so that the 2 pi times the distance over 360 is over here. With that said, this is the problem that they're giving. This is the thing we're going to plug it into. So I think that's the thing on the next page. And I think they derive this in the book and in that problem, but I don't know if I did it in my notes or not. But there it is again, if not. Ooh, it's like 30 seconds to fill that thing out and try to figure it. Give you a few more seconds. But for pi, you want to use 3.14 for the distance. They give you the distance, so that is a number you might have to plug in. They give you the angular size, so that might be a number you have to plug in. So you might have to do a little bit of maybe like PEMDAS work here or something like that. But I hope it's pretty straightforward. Plug this number in sort of thing. Okay. I think I have it to shoot. I think I have it to 2 decimal places. It's 150 million and 60 and then multiply that by 5. Yeah. Oh man, I can't. I think I did this to 2 decimal places, but there is a chance. If I'm being honest, there's a chance I might have done it to the nearest kilometer. So that's a good question. Okay. All right, so let's take a look at this. Did I do a slide with this? I don't know if I did a slide with this. Okay, so that looks right. 138.33, 138.33, 33. Yeah, that's it. 133. That's it. 1.3 million. That's good enough. That's ooh. So you might want to put like times 10 to the, what is it, 6 here? Be careful with this. If you're getting this, it probably looks like 1.31 e to the 6 is what your calculator will spit back at you sometimes, like a little a capital E. And when that calculator says capital E, that's like stands in place for times 10 to the that power. It's scientific notation is what they're giving you. So we will go a little bit more into scientific notation later as well. But it looks like a lot of the people are answering correctly. So the distance was 150 million. So you did have to convert that to maybe like millions. Ooh, and a few more seconds. Determine which of the following is steeper. So this is sort of like a, I don't know what you want to say, like a slope, right? If I have a zero slope that's completely flat, the larger my slope gets, the steeper the thing is. So which one of these is larger is another way of saying which one is steeper. And we have a railroad track with a 3% grade or a railroad track with a slope of 1/25. And so hopefully you're not just randomly guessing. But I hope what you do is convert those. So either convert the slope to a percentage or convert the percentage to a fraction. And tell me which one of those fractions or tell me which one of those percentages would be larger. So you're going to have to do some converting to a common base somewhere in there. So which one did you convert? I would have personally went with the 1/25. To convert 1/25 to a percentage, what does it convert to? So if we convert 1/25 to a percentage, it'd be like multiplying top and bottom by 4. You get 4 out of 100 or 4%. I think that'd be the easiest way to go. You could try to do 3 out of 100. You could do 3 out of 100, 1/25, and do the little butterflies. See which one multiplies to the largest one on top. There are a few different ways to compare fractions, but that's all we're doing here is comparing two fractions. What is next? The slope of a roof with an 8 and 12 pitch. So you can go to 2 decimal places. You can give me a fraction. A reduced fraction is what you should do. Ooh, it shouldn't take too much longer. So if it's 8 and 12, what does that mean? If we're talking about pitch. So they give us a few different ways to talk about the same thing. There's like slope, pitch, and grade, I believe is what they go. And pitch would be 8 and 12. That means it goes up for every 12 that it goes over. So what is the slope? Man. All right, so there's like one thing you got to do on this thing. You got to put the 8 over the 12, and then you got to reduce it, right? So 8 over 12 reduced should be 2 over 3. We divide both the top and bottom by 4. So this should be 2/3, or you can give me 0.66 repeating, 0.67. 2 divided by 3. What else is getting said? 60. Okay. So 8 over 12 wasn't reduced. So you got to reduce it if you want to slope, or you should reduce it. If not, y'all can put in almost infinitely anything, and I have to go with it. So for this, you definitely, I guess you could use a fraction if you wanted. But how much does a roof rise in 15 horizontal feet? So there are a few different ways to figure this thing out. But we just have the slope from this thing. And they want to know the rise. And this is the run that they're giving us. So this is 15 horizontal. Would be horizontal, indicating that it would be the run that they're talking about. Okay. There are a few ways to figure this one out. So one way you could do it is by what? Multiplying 15 by 2/3. Did I get it right? Oh, that's the correct sound. It's a womp womp sound. Is it?
Incorrect? I didn't.
So it should have been 10 feet. We're all getting 25, 10, 10. It looks like a few of you getting 10. You could come up with equivalent sort of fractions, right? You could go 2 over 3 equals x over 15. Did I do that in the next slide? I can't remember. Maybe I did. Something like this. We're doing rise to run, right? Oh, excuse me. Rise to run. You could cross multiply 3x equals 30. Or you could just multiply top and bottom by 5. You'd still get 10. So there are a few different ways you could probably do that. They are all correct. There's a few ways you could do it that probably are not correct. So we want to look at this thing. Ooh, calm down there. We want to find, let's say, find the shortest possible walking distance between the two locations. And the two locations that we're going to look at are the bus stop and the library. So we want to go walking distance. So we're going to walk down these blocks, the shortest possible distance from the bus stop to the library, walking on the street. So each one of these blocks is 1/8 of a mile. Each one of these blocks is 1/5 of a mile. And there's a few different paths you can take, right? But they're all going to be the same. You're still walking this many blocks this way and this many blocks that way. Okay, so I want to go over how to do this one. Let's see what we're getting. Are people getting it right? 0.95, what are y'all getting? 0.95, 0.95, 6/8 each. So you want to add them together. 19/20 is 0.95. It's the same thing. I just didn't put in there. So 19/20 is good. So how are you getting that? So you're going 6 blocks that are 1/8 of a mile, and you're going one that is 1/5. Or you do 6 1/8 or 6/8 plus a fifth is going to give you 0.95. The other thing, now we want to know as the crow flies or whatever they say. We want to know the straight path going there. So again, we are going 6/8 of a mile this way. We are going 1/5 of a mile this way. So how do we find this thing right here? And round 2 decimal places, I think you'll be all right. So what's the formula you need? Where are we at? So what formula are y'all using? Anyone want to help your classmates out? It should be the Pythagorean theorem. A squared plus b squared equals c squared. So that was a cult that like believed in a bunch of numerology and stuff. Pythagoras was kind of their leader, but there's a whole cult kind of around him. All right, so you should have got something like 0.78, somewhere in there. And did I not do a slide? Oh, shoot. So how did we get 0.78? We did 6/8 and we squared 6/8. So if you do 6/8 and you square it and you do 1/5 and you square it, you should get something like 0.6025. And when you take a square root of 0.6025, that should give you the 0.78. And now they want to know how many different paths are possible to walk that are the shortest path. So I think I queued it up a little bit. Multiple guess. Let's see if I count them right. So basically just don't go backwards, right? How many different paths are there going forwards towards the library? This is a weird question. I feel like it's kind of straightforward, maybe. Maybe not. So basically count the paths. How many are going up? There should be like 7 different ways to go up that are not going back. So hopefully we're getting this one correct. What? We're not getting 6. You can go up. That's 1, 2, 3, 4, 5, 6. And then the final one, you can also go on this street and go up. So maybe you're thinking there's like 6 blocks this way. But this is the thing with like, there are 6 blocks, but there are 7 streets because you have to count the endpoints. Should definitely be 7. Okay, so we're going to find the area in acres. So this is the picture that they give us. And then the problem says, we're going to basically use this picture, but the stream frontage, we're going to change this to 200. We're going to change this to 800. Getting a little bit ahead of myself. So they want us to find the area. And so in order to find the area of this triangle, what do we need that we don't have?
Could you repeat that?
So what do we need that we don't have? We want to find the base here, right? So we need the 2 legs of the right triangle in order to find the area. So what they're giving us is not a leg, right? We want to recognize that this is like a hypotenuse. This is not the thing that we should be working with. We should be working with this thing and this thing. In order to find this leg, what are we going to need to use? And we used it in the last thing. It was the Pythagorean theorem. So how do we set this up with the Pythagorean theorem? This 1200 should be in what spot? What variable is that?
The C.
I think I heard C. Is that what I'm hearing?
Yes.
Yeah, okay. So this 1200 should be the C. This 250, it really doesn't matter which one you plug it into. A and B are kind of interchangeable. So I plug it into one of them. And so from there, I want to figure out what this thing is. And then I want to do my area. So area, we went over it last time, should be a half base height for a triangle. And then the last little tidbit of information you might need is 1 acre is 43,560 feet squared. So again, we're going from feet square to acres. So from feet to acres, feet are smaller than acres. So small to big, divide the pig is the way that goes. You ever heard those ones? It's like big to small, multiply all, small to big, divide the pig. So you should be dividing by this number to get to acres. And again, we're gonna go into like a whole unit. There's nothing but unit conversions and unit analysis is what it's called. So there's an entire chapter over unit analysis. And so we will go a little bit more into like whether we should divide or multiply. So I'm skimping a little bit on like that in this section, just because we're going to pick up on it more later. So, and then let's get to the question. So 43,560 feet squared per acre. And so now we got this question. I marked out the numbers if you want the prettier numbers in there. We need to figure this out. So again, the approach was to use the Pythagorean theorem to find the missing side. So you're gonna have to plug this thing into the Pythagorean theorem, plug it in correctly, hopefully. It should not have said 12. This one will be different, right? It shouldn't be 1200. Now we're doing 800. Hope I did that correctly. Hopefully I did it correctly when I did solve this. And so we want to find that missing side. We want to find the area. And then divide that by 43,560. Whatever you get in the end to get to acres. Did I have the right numbers in the previous slide? I think I was doing them with the numbers that were there originally and not the corrected numbers. It's around.
Professor?
Oh yeah, what's up?
One thing that's confusing me is, do we use the numbers from this slide or from the previous one?
So these are the numbers. This slide is the one with them corrected. So it like they started with the example from their notes or whatever, the notes in the book,
Okay.
and then they gave us a problem that changed out the numbers. Basically, is what they did from their example.
Okay, thank you.
So these are the corrected numbers. It should be the 800 and the 200 for this one. So yeah, I don't know if I know I probably did them with the previous numbers for the previous one. I think I put the wrong numbers in there in the previous slide, to be honest. It should be these numbers. So we're doing what? 800 squared minus 200 squared. And we do the square root of that thing. Should give me somewhere around 774.59666692. That is my base. So now I'm multiplying my base by what? 200. 154,919.338. 3338, sorry. And so that I need to divide by 2 because it's a triangle. And then take this, what is it, 43,560? Yeah, that's it. And I divide by 43,560. And that gives me the number of acres, should be 1.778. And I round that up to 1.78 acres, I believe. Where are you at? 0.78. 775 feet. I'm not seeing where that's coming from. 1.786. Okay, that's good. So the 1.78s are there. I'm not seeing where these other, I'm not sure where these other numbers are coming from. Okay, so these are similar triangles. We want to determine x. So the first thing we want to find is x. These are similar. We should be able to set up fractions, or there might be an easier way to do this one if I'm being honest. Okay. So we should be able to find x on here. This one I feel like is easier. Yeah, this one's easy enough to where you probably don't even have to set up fractions. There's an operation you can do that might be even easier. Okay. Is it going to the next slide? Where's it going? There we go. All right, so it looks like everyone got that answered. It should be 4. X was 4. Y, what would Y be? So if you want to set up equivalent, sort of where we're at, where's the timer? 10 seconds. All right, so if you want to set up equivalent ratios, you go 10 to 5 equals 6 to Y. If you really wanted to do that. The easy way to do it is what? Going from 10 to 5 or dividing by 2. That's probably the easier way to do it. So 8 divided by 2 is going to give you 4. 6 divided by 2 is going to give you 3 is what you should be getting for this one. All right. All right, so they give us the solar axis problem in the book. And then they want to change it up a little bit. So basically what they're going to do is create equivalent sort of, or not equivalent, a proportional similar triangles here. So if we're looking here, the height of the fence to its shadow should be proportional to the height of the house and its shadow. So we don't want the basic problem says we don't want the shadow of the house to like cast past the shadow of the fence. So we're going to set it up at a certain angle so that it's at the same angle here. This angle of inclination is the same so that it never casts a shadow past the fence. It's a homeowners association sort of rule. So here with these numbers, I have 12 to 20 is like one sort of ratio I would write. So 12 to 20. The other thing would be this height right here. And we're going to compare that to this entire thing of like 50 right here. So height to its shadow and its height to its shadow. So this is a sort of similar triangle ratio you're setting up, hopefully. But now we're going to change these numbers. So now they want a 12-foot fence. Now this shadow is going to be 25 foot and this will be 60 foot. So if I do 60 and 25, did I do that right? Let's see. I got the picture on the next page. But if I do 60 and 25, I'm going to have to add them together to get to 85, right? But you should be able to set up similar proportional. There's similar triangles. You should be able to set up fractions that are proportional. So 25. That did not give me enough time. Let's go back. Stop it. Let's restart. There's a restart button. Sorry about that. Ooh. This is the old problem. Should I go back? Woo. This is when I want to restart. What am I doing? It went back far. All right. So assume the solar axis is given. Here's the picture. We want to set up a similar triangle. And figure out what the height of our house can be. Two. All right, so you should be able to set up similar fractions or equivalent fractions for similar triangles. It should be 12 to 25 is h to 85. That's how we're setting this thing up. So it should be 40.8. Okay, so I want to talk about maximizing area and maximizing volume. Okay, so if we have something like a perimeter, we know the perimeter of a rectangular prism is two of the width and 2 of the length, and the area is the length and the width. And so if we have a set perimeter, let me start graphing this thing. So give me a set perimeter, I don't know, maybe have 10 feet of, let's do 12 feet of fence. And it's not going to accept it, but let's say I have 12 feet of fence I'm working with. That means I have a perimeter of 12 feet. So I'm going to have a formula like this. I'm also going to have a formula that looks like my area is my length times my width. And so I want to do a little bit of solving with this thing, my perimeter. But basically what I'm going to do is plugging the information I know about my perimeter into my area. And I'm going to try to maximize my area formula is what I'm trying to do here. So if I wanted to solve this perimeter for my length, I would subtract the 2W over. So my 2L would be equal to, what was it, 12 minus 2W? And then the next step, I would divide everything by 2. So I'm dividing that by 2. I'm dividing that by 2. I'm dividing that by 2 to solve for L. And so I have these two formulas. This is coming from my perimeter. This is coming from my area. And then what the computer is doing is it's plugging one into the other. So if I do this again, and instead of L, I do 6 minus W. If I substitute that and put another W, you might notice these two things are the same. I'm just plugging in 6 minus W into my L. But if I look here, if I have 12 feet of fence, the thing that maximizes my area, the maximum area is 9. So this is the maximum area that you're going to get from 12 feet. What that means is that each side has to be 3 feet. So this is my width is 3 feet. If I go plug it back in, it's also going to solve my length is 3 feet. What this is telling me is that a square would be the thing that maximizes my area for rectangular prisms. And so if you look at this sort of thing, we can see that what's going to maximize our area is actually going to be when the length and the width are going to be the same size. And you can do this with different set perimeters. It will give you the same thing, right? It'll always be a square that maximizes your area. If you want to talk about triangles, it's equilateral triangles. If you're talking about all 2D figures, the circle is actually the thing that maximizes your area, given a set perimeter. If we want to extend this, so what do you think a 3D object, if we have like a 3D rectangular prism, what do you think would maximize the volume in there? So what sort of 3D object would maximize the volume of a rectangular prism? If a square maximizes the area of a rectangle, what would maximize the area of a rectangular prism? Hopefully you can deduce it would be a cube, right? We could do a sort of similar thing where we plug in the surface area to the volume of a cube and try to maximize that formula. The thing I really want to know is how much will the material for each box cost? So if we have this thing and we need to make it with a volume of 8 cubic feet, how much would that thing cost if it's 15 cents per square foot? So the first thing you're probably going to do is want to figure out how big does the side have to be? And we want a cube. So how big does the side have to be for it to be 8 cubic feet? Oh man, did I put the right solution in this thing? I don't remember doing this. Hopefully. And you should round it to the nearest dollar. Probably put a dollar sign in there. Solution for this one, but maybe I did. So we're doing 8 cubic feet. The first thing you want to ask is, what is one side going to be? What is the measurement on one side? Oh man, I didn't do the right thing. Dang it. That's why. Okay, so I definitely got this one wrong. All right, so we gotta move along. Let's keep moving. We're already over time. I'm just like, I'm kind of baffled at this class. It should be 360. And in order to do that, did I do a slide? I can't remember if I did it in a slide for this one or not. Nope. Okay. So let's go back and talk about this a little bit. We want a volume of 8 cubic feet. So in order to do a volume of 8 cubic feet, where are we at? 240? That was me. I forgot to multiply by 6. I multiplied by 4 instead. I didn't realize that it's got 6 sides. It should be 360. And going back to this, if it's got a volume of 8 cubic feet, each side has to be 2 feet. So each face is 2 by 2 feet. So each face is 4 square feet. There are 6 faces. So 6 by 4 gives us 24 square feet. And we do 24 square feet by 15 cents per square foot should give us 360. And we're almost done. There is just 3 more. This one, we want to find the lengths of each one of these sidewalks. So that something along the lines, they say build sidewalks last. In other words, you let people choose their paths, and then you pave the sidewalk over where they walk. And so we want to find, the first thing is this bottom right one. So we've used it enough, but I believe we're using Pythagorean to find this bottom right one. So I'm going to skip ahead. So figure out that thing. You round it to 2 decimal places. Jesus Christ, man. Oh, man. I'm just like baffled that half the class is not here the day before a test. So I don't know how to say this, but like you don't do what you're just like what is required in this class. You're gonna this is college. You will fail. Like it's, in high school, you don't just get passed along through class. Half the people aren't watching the videos as they should. Half the people aren't even here the day before a test. And then some of the people here are half here. All right, we gotta get along. I'm not spending like all day on this assignment. Like, y'all need to be like a little more active, a little more responsive on some of this stuff. Like, I'm not trying to fail people, but like, this is not the way you take a college class, and I don't know how to be nice about it. Like, so many things aren't getting done that just need to get done. And I'm making like these slides, and it takes a lot of time to, and it's a lot of effort to put into this class, and it's just like, no one's doing anything. So we're gonna talk about this left side. So how do we find this left side? We have a missing dimension here. We have a missing dimension here. So if we want to find this missing dimension, this is 15. This whole thing is 40. 40 minus 15 will give us 25. We want to find this dimension here. So we found this sidewalk. We want to find this sidewalk. So how do we find the bottom? And see, like, I'm like, the way I teach, I ask questions, and like, that is the Socratic method, right? That is the way you learn. Like, you don't learn by like having me up here dictating the facts to you. Like, that's not the way you learn stuff. And so like, I really need like y'all to respond to me when I ask questions. Like, that's the way this class is going to move along. If y'all keep like, if this keeps going like the way it's going, every class is going to go like 30 minutes over time. I don't know how else to do it. Like, this is how teaching gets done. And it's not just y'all. This is like the other classes being the same exact way. Both of my classes are being the same exact way. And like last semester, like I was teaching the same class. They didn't have the quizzes. Like, so it was even more dry for them. And I can't say like the response was this bad, but I'm just really worried about a lot of people. But if we do this is 30 minus 15. That's the bottom there. I guess I shouldn't be worried. I'm still going to get paid the little amount that I do. Either way, whether you pass or fail the class, I'm still getting paid the same. So I don't know what to do. If you have any suggestions, I'm here for it. But like, if I ask you to do something and you don't do it, there's not a lot I can do. I can't force your hand and force your actions. And to be frank, like, I'm going way beyond what any one of my professors in my college career would have ever did for me. Like, I really don't understand the response this semester. It's not good. This is 15, this is 20. What is this missing side of the sidewalk?
Is it 20 or 25? Because in the slide it's 25, but now it says 20. So
Did I mess it up? It should be
I-
25,
okay.
right? Because it's 40 minus 15. And I don't mean to rant at you if you're doing the correct thing, right? But like, it's just like so many people aren't. And I need a little bit more activity from everyone, if I'm being honest. All right, so using the Pythagorean theorem with 10 and 25.
For some reason, it's not letting me put in my answers. I can't turn them in.
Can't submit them. Can you reload the page maybe or something? Because I don't know.
It's not letting me put the finish thing button.
The finish button. Try to reload it. Try to come back in on the web page on the Join My Quiz, I guess.
All right.
So 29.15 is correct. We're doing Pythagorean theorem with 10 and 25. And so now we're looking here. We want to do this triangle. So I did this, but basically you're going to look here. You want to find this sidewalk. So in order to do that, we got to kind of form a triangle. So you got some options of what sort of triangle you want to form. But I think the best way is probably to do like a right angle here. That way we can employ the Pythagorean theorem. So if we want to know the top here, the top is the same thing as just this top thing. So that should be 30 meters. If I want to know this part, well, I know this is 15 meters. I know this is 15 meters. I know this thing in the middle here has to be what? 15 is going to give me 30. I believe there are 10 meters difference there. Now I think what we're doing is a Pythagorean with what, 10 and 30? So what are we getting there? $31.62. Okay, so this one is, I think, pretty straightforward. It's a rancher. He's got to just design a rectangular corral. an area of 400 square meters. So we have a set area. She decides to make a corral that measures 10 meters by 40 meters. How much fencing is needed for this corral? Have they found the most economical solution? So we've gone over this already. So obviously that is not the way you want to construct it. So how do they want to construct the corral? Can you find a way that still gives you the 400 but gives you less meters? What are we saying? So how many meters of fence are they using there? How many meters can you use? That's the things I would look at. Twenty times 20 is what you want to do. Yes, you want to make a square out of it. So each length is 20 meters. And so how much fence would you use if it was a square? And how much fence are they using is the other two questions. So now we know the side links. Now we just need to know how to find the perimeter. So if we're doing 40s and 10s and we add them together, what are we going to get? If we do all nothing but 20s, what are we going to get? And does it match what we're expecting with what was said about the square maximizing the, yeah, so 100 would be the big one. If we do 10s and 40s, it will give us 100 perimeter. If we do nothing but 20s, we got 4 20s, will give us what, 80? So you're talking about 100 meters of fence versus 80 meters of fence, and it's going to fence in the same exact area. If he was really smart, he'd do a circular pen, but I guess he's not that smart. Or she, I guess, is a rancher. Yeah, 80 meters. Yep. That's it. And then there's one last question. And it is I don't know. It is a lot, if I'm being honest. And so I kind of worked through it. So a square maximizes the area. So if we're going to do this, we want something that is what? 20 meters in each side. If we have 20 meters each side, it's going to be 80 feet total fencing versus the 100 that she was doing the other way. So it is a dark and stormy night through the beat of the wipers. So you're driving a truck. They have this really, really elaborate story here. But basically the story is you're going to go over a bridge that says it's got a 40-ton limit. You got a truck. It's called White Lightning. Yeah. It weighs 16.3 tons with you and your gear. Trouble is carrying capacity. Oh, I didn't miss that one too. Your truck is 16.3 tons. You're carrying a water tank that is full of water. The empty weight of the tank is printed on the side, 1750 pounds. And they give you this thing that tells you that water weighs this many pounds per cubic inch. So what we want to do is we have a tank. We have the dimensions of the tank. And we want to figure out how much the water weighs in the tank. So the first thing we need to do is find the volume of the tank. How big is the tank in cubic inches? And so this is something you'll need. Well, you might want to convert the feet to inches, but you will need the volume for a right cylinder is what they're called, I guess, right? We need the volume for a right cylinder. And so we know the height of this thing, of the cylinder, would be 264 from the problem. We know the radius would be 78. But if I asked you to find the volume of a cylinder, I feel like this first part should be doable. Given a height, given a radius, you should be able to find this. After this, being honest, I really feel like it belongs in the unit analysis section. So we know that water weighs this many pounds per cubic inch. So if we want to know how much the water weighs in the tank, this is how many pounds the water is going to weigh in the tank. We also have the empty tank that we're figuring in there. And then if I want to convert it to tons, I know 1 ton is 2,000 pounds. So I'm going from small to big. So I'm going to end up dividing by 2,000 pounds to get the tons. So this is a 91.97 tons, I think, is what the water weighs. And then the problem also said something about the truck weighing a couple tons. So already we're way over the ton limit. So no, and still no, it's not going to be no. You're not going to make it over that bridge. Don't do it. That is the end. That is the final problem. If you have any questions, I am here. And I think I'm going to hit stop on the recording and stop on the share. But that is it. I'm going to end this lesson. And that's it.